Hey everyone, we're continuing on with our triangle unit. Day 2, we're going to talk about some other ways we can prove that triangles are congruent. We learned on Monday that they can, on Tuesday, that they're congruent if and only if all their sides and all their angles are congruent, which is the basic underlying rule of triangles. But what we're able to do from some other theorems and postulates that we'll learn today is be able to prove with less information that all the sides and all the corresponding angles are congruent based on what we know from what we're given. So we're not going to have to go through and show that every single angle and every single side is congruent. We're going to be able to do it if we show some pieces of information about the triangle that we know are congruent. And it's all just because of the way triangles work. So the first thing we're going to start with is the triangle rigidity property. What that tells us is a triangle can have only one unique shape if it has certain specified side lengths. There's only one way the three sides of a triangle can go together. If we are given measurements of 8, 6, and 10, there's only one way we can create a triangle that has sides of 8, 6, and 10, and it becomes like a unique triangle. So there's only one way to do that. So that's what we're going to work with. We're kind of building on that concept. You'll learn later on why that is, why it's only one unique shape for each triangle based on the side lengths. So the first thing we have is what we call the side postulate. Again, we're trying to show why two triangles are congruent. The side postulate tells us that if three sides of one triangle are congruent to three sides of the other triangle, then the triangles are congruent. It's half of the property we learned yesterday, where it says that triangles are congruent if and only if all three corresponding sides and all three triangles. Well, this is the side part of it. We can say based on the sides, triangles are congruent. So we only have to know the three sides are congruent. So we have some examples. We're told in the example on the left that side AB is congruent to side DB. We see the two slash marks there. We're asking, and then we're told that point C is the midpoint of segment AD. What the midpoint means is that the middle, so the left side of the side AC, is equal to side CD. So that tells us right away that these two sides here are congruent as well. Of our two triangles, we see two triangles in the picture. And we're trying to prove that it's both triangles are congruent. And what's going to happen is the triangles are sharing the side. They share the side BC, so that automatically makes BC congruent to BC in the two triangles. So we've already shown that all three sides of these two triangles are congruent. So these two triangles are congruent. So all we're trying to do, are all three sides congruent? Is there a way to prove that? Oh, yes, there is. Okay, then we can say the triangles are congruent. If we can't say the two sides, that all three sides are congruent, if we can't say that, then we have to say that the triangles aren't congruent or we don't have enough information. Example on the right, similar thing. We have a parallelogram with a diagonal cut from T to S. We see two sides are congruent. The two top and bottom are congruent. The right and the left side are congruent. We also know, again, that we have two triangles formed. This here, triangles share this side again. So like we learned in the last example, that side makes the side where they're shared, it automatically makes them congruent in the two triangles. So again, we've shown that all three sides of our triangles are congruent. So we're able to say the triangle RST and UTS are congruent. Does that make sense? Everybody kind of see that? Okay, we're going to build it now. So we have our side that we know of. There are 4 of them we're going to learn today that we'll need to know as we kind of go forward, and there'll be questions about why are these things congruent. The included angles. A very specific thing we need to know because it's one of our postulates is going to help us if we know what the included angle is. An included angle is the angle that's formed by two sides of a triangle. So it's simple. It's exactly what it sounds like. The two red lines are sides of a triangle. We have our included angle as that angle that those two sides form when they meet. That's our included angle. that make sense to everyone? Everybody can kind of see that? Because if you can understand that, then this next postulate is going to be relatively easy. It's called the side angle side postulate, where we abbreviate it SAS so we don't have to write it out all the time. When I see SAS on a test, I know right away that it's side angle side, and that will be the proof of why the triangles are congruent. This states that if two sides and the included angle of that triangle, one triangle, are congruent to the two sides and included angle of another triangle, then those two triangles are congruent. So here now we've said that we needed to prove that all three sides and all three angles are congruent to prove that triangles are congruent. But here we're going to be able to say it as long as we know that two sides and one angle are congruent. The specific angle, it has to be the included angle from the two sides that are congruent. But if we know that, we can say for a fact that those two triangles are congruent, no questions asked. Does that make sense? Okay. Here's our example. We see is they're asking, is triangle ABC congruent to triangle DEF? We kind of look. We have my corresponding sides. AC is corresponding to DF. That's congruent. AB corresponds to DE. That's congruent. And then we're told that angles A and angle D are congruent. They're the corresponding angles. But we know for sure two sides of the triangles are congruent. The included angle of those two sides is also congruent. So I know for a fact that we can state without question that triangle ABC is congruent to triangle DEF. Does everybody see that? As long as you have two sides and then the angle in the middle of those two sides congruent on two different triangles, the triangles are congruent. Okay, here's some for you to try. I want to take a look. Determine if we can say whether the pairs of triangles are congruent by the side angle side postulate. We're just looking specifically at that postulate. Take a few minutes, enter your answers in the Edpuzzle, that yes or no they're congruent, and then come back and check and see how you did. Okay. So the answer is, when I kind of look, we're looking side angle side. Remember, it's the two sides and the included angle of those two sides. In triangle one, picture in triangle one, I have two sides are congruent. The included angle is congruent. So yes, these are congruent by side angle side. Excuse me. Triangle two, we see we have two sides that are congruent. AB is congruent to XY. AC is congruent to XZ. So they're congruent, but the problem is it's not the included angle. We have the included angle in XYZ between the two sides, but it's a completely different angle on triangle ABC, so we can't say they're congruent. We don't have enough information there. Does that make sense? Okay, the third one. We have when we look at it, we're given parallel lines, so I know that we're looking at parallelograms. I have the top and bottom of my parallelogram are congruent. It shares the triangle share side, the middle side there. That's congruent to itself. So we know for a fact we got two sides. We're trying to figure out, do we have included angles? And they've identified angles 1 and 2. And when I kind of look at it, I have, if I kind of do the bottom of the triangle and the side that they share, do that one in red for triangle 1. I'll do the other side in blue for triangle 2, my second triangle, to kind of show it. When we're looking at that, we're looking at the two sides that are congruent have an included angle. So we have to remember, are those included angles congruent? Is there a way we can prove they're congruent without being told they are? Remember, we don't have the arc on the corner, so I don't know if they're congruent yet, but I think back to what we learned last unit about parallel lines and transversals and alternate interior angles being congruent. That tells me that angle 1 and angle 2 are congruent because they are alternate interior angles for the two parallel lines. So we are able to say that triangle SRP and triangle QPR are in fact congruent. So yes. Does that make sense? Is everybody able to see that? You may not be told. You're going to have to use some of the information we've kind of learned as we've gone through this to say, okay, yeah, those triangles are congruent because of this. Again, this unit would be, there are proofs we can do to specifically prove these triangles are congruent based on what we have, but I'm not having us do the proofs. We're just using the postulates that we would use in the proofs as our final thing, saying, yeah, these triangles are congruent because of the side angle side postulate. Okay. Included side. If we know what included angle is now, if we can take a guess, what do we think the included side looks like? What does it mean? If you guessed that it is the side between two angles in a triangle, you are 100% correct. That's what the included side looks like. So as we kind of bring up our diagram again, we have two angles of a triangle. The side between those two angles is the included side. Again, if we know what an included side is, we can use that in our angle side angle postulate. Look at it. When we talk about included side, it's the side between two angles, angle side angle. It's the included side has to be congruent. So when we look at our diagrams here, we talk about what this means. This now tells us that if we have two angles that are congruent and the included side of one triangle is congruent to the included side of the other triangle, and the two angles are congruent, then the triangle has to be congruent again. So again, we're going on triangles are congruent if and only if all three sides, all three angles are congruent. But we're being able to prove based on these postulates with less information. Here we don't even know the other two sides are congruent yet. We just know one side's congruent, but we're able to say the triangle is congruent because the other two angles are congruent. Does that make sense? So as long as we kind of have two of the three for each, like if we have two of sides and one angle, we can say that things are probably congruent. Again, here's our example. Angle E and B are congruent. Angle A and D are congruent. The side in between those two angles is congruent, so our included side is congruent. We have congruent triangles in that picture. A couple more examples. We're kind of taking a look at it. Is ABC and CDA congruent when we look at these two triangles in the rectangle? We're looking, we have the alternate interior angles of our, what probably are parallel lines, are congruent. The side in the middle, shared by both triangles, is going to be congruent to itself always. So we have the included side of two angles congruent. We know that yes, those two triangles that form that rectangle, they are congruent. Does that make sense? Everybody sees that. Second one, is ADB congruent to CDB? So here we got to kind of look and see where are my congruent sides. Do we have enough information? I see angles that are congruent. Those are congruent. These two here are congruent. So they tell me I have two angles. The problem is the included side that I know definitely is congruent is this side. So I know for a fact that that's congruent because it's congruent to itself. So can we say these are congruent yet? Yes or no? What do we think? Here's the one piece of information that we have to remember. I have two angles of each triangle are congruent. The third one then has to be congruent because all triangles add up to 180 degrees. So if two are congruent, then all three are congruent. Now we can say we have included angles or an included side between two angles because the angles at point B and point D for both triangles are congruent. The shared side, so yes, these are congruent. Just got to kind of think through as you're kind of looking at it. You may not have all the information marked off in your picture, but you may know enough in the back of your mind of what we've learned to kind of fill in the rest. Okay, last theorem, angle side angle, or angle side, sorry. Here they're telling us if there are two angles and a non-included side, so now we're not talking about the side between the two angles, We're talking about one of the two other sides in each triangle. If those are all congruent, then again, we can say that the two triangles are congruent. And my picture is totally of an included angle, so that's not going to help us. So if we kind of forget about that and then think about, if I kind of say that this side here is congruent to this side here, that is what we would be seeing in our angle side theorem. We're not going to worry about this blue mark here. We're going to kind of white that out so you don't see it. I will fix this for the live class. But what we're looking at here now is we have two angles. We have a non-included side that are congruent. We can say that those two triangles are congruent. Does that make sense? Everybody sees that? We're all good. Sorry about the confusing picture. Okay. So here's some examples I want you to try. It kind of ties it all together. Are the two triangles that they're asking about with the information they're given, are the triangles congruent? If they are, state why. Which postulate did you use? Side, 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 angle, angle, or angle, side. And if they're not congruent, is there another piece of information you would need to then be able to say, yes, they're congruent based on this postulate? And to pick a postulate you want to use, tell me what other piece of information you would need to say, yes, they're congruent, and enter all your answers in the Edpuzzle. Then come back and check and see how you did. All right, so for number 3, they are congruent because we can say, because point D is the midpoint of AC, I know that AB and BC are congruent because they told us in the picture, in the what do you call it? In the write-up, that they're 3 feet, so they're congruent. So this side here is congruent to the other side. That's one piece of information we know about the triangles. They told me that D was the midpoint of AC, so that made these congruent. So I have two sides are congruent. The shared side BD, third side, they're congruent because of the postulate side, side, side. Make sense? Everybody get that one? Okay. Question 4, when we look at question 4, we can't prove their triangles are congruent right now because we don't have enough information based on what they're telling us. What they've told us is that angle A and angle C, and remember, we're looking at these as completely different questions. We're not worried about what we figured out in question 3 there. We know angle A and angle C are congruent, and sides A, B, and BC are congruent. That's what we know. So we can't prove anything's congruent right now. We would need one more piece of information to use to kind of figure out, can we prove they're congruent? So what did you say you could use? If you said you would need to know if angle ABD and angle CBD are congruent, so I'll just kind of write them in. If you needed to know angle 1 and angle 2 are congruent, good job, because that would be angle, side, angle. We know the side's congruent. 2 angles would that be congruent, and off would go. The other thing that you would need to know, another option, would have been, is BD perpendicular to AC? Because if BD is perpendicular to AC, that makes both of the angles at point D there right angles. Now we have angle, angle, side, and we could say they're congruent that way. Does that all make sense? Everybody kind of sees that? Okay. So here's what we learned today. We know that if we have the 3 sides of a triangle are congruent, we know the triangles are congruent. It's a unique triangle. If we're looking at one triangle, they're unique. If we know the 2 sides and the included angle, so the side, angle, side postulate, then those triangles are congruent. If we know angle, side, angle, 2 angles and the included side are congruent, then we know those triangles are congruent. The third one is side angle, angle, side. Again, if we know the two angles and a non-included side are congruent, then we know the two triangles are going to be congruent. The third one that they have listed there is side, side, angle. If you know two sides and a non-included angle is not sufficient to prove that the triangles are congruent. When you think of it, you could end up forming two different triangles. From their picture there, we could have an acute triangle where we drew a line this way. We have a triangle. Or what you could do is you could flip 6 all the way open the other side, and then we could connect it from the 30-degree angle there and have a different total triangle. So just because two sides in a non-included angle doesn't make it true. The other thing I like to point out is what math teachers really don't like to see is another way to write this would be this. And we really don't want to see that on math questions. So that's why I say it doesn't work. Make sense? Okay. One thing to remember, we talked about the three sides. We knew what they told us about triangles are the triangles are congruent if all the sides and all the angles are congruent. We've also learned today that if the three sides are congruent, we can say the triangles are congruent. Unfortunately, we are not allowed to say that if we know the three angles are congruent. Just because the three angles are congruent, it's not going to make the triangles congruent. What it does do, though, is it does make them similar triangles. So you can make angles, have the same three angles in a triangle and make the sides different lengths, and that's going to work. They'll be similar. We'll learn about that coming up after vacation, why that is and how we kind of see it. But just because the angles are congruent, again, does not make the triangles congruent. You need to have at least one side then being congruent. Because once we know if all three angles are congruent, and then once we know one of the sides is congruent, we can use either angle, side, angle, or angle, angle, side to prove the triangles are congruent. Does that make sense? Everybody sees that? Okay. Have a good day off tomorrow. If you celebrate it, have a good Easter. I will talk to everybody on Monday. See you in class.